Hello! In this video, we're going to prove the following theorem. Let F and G be families of sets. Then the union of F, set minus the union of G, is a subset of the union of F set minus G. Now, if you recall, given a family of sets F, to say that X is an element of the union of F means that X is an element of some set in F. Now, we're trying to prove that everything in this set belongs to this set. So give me an arbitrary element of this set. I'll call it X. Our goal was to show that X belongs to this set. Now to start, this means that X is an element of the union of F and X is not an element of the union of G. Well, since X is an element of the union of F, this tells us that X is an element of some set in F. I'll call that set A. But what does it mean for X to not be an element of the union of G? Well, we know what it means for X to be an element of the union of G. It means that X is an element of some set in G. So to say that X is not an element of the union of G means that this is false. So it means that X is not an element of any set in G. So we must have that A is not an element of G. Because if A was instead an element of G, then X would be an element of a set that is in G, which we know is not the case. So we see that A is an element of F, and A is not an element of G. These two facts tell us that A is an element of F set minus G. And now we see that X is an element of a set that is in F set minus G. And that is precisely what it means for X to be an element of the union of F set minus G. And now putting this together, we see that under the assumption X is an element of this set, it follows that X is an element of this set. Since X is arbitrary, this means that every element of this set belongs to this set. And that is exactly what we wanted to prove. So this completes the proof. And so yeah, that's